This might put me out there as a huge nerd, but I actually have fun solving rational equations. All right. So we've talked about in the past here multiplying equations to clear all fractions. That's kind of the path I want to take here, because not a lot of people like fractions, which I get. But if we multiply everything in that equation by a common denominator, then all the fractions go away. So we have 1 over 2x plus 3 over 10 equals 1 over 5x. So I need to think in my head, what is something that 2x, 10, and 5x can all go into? Well, I see they have an x, so we're going to have to include that. If I'm thinking about 2, 10, and 5, they all go into 10. So here's what we're going to do. We're going to multiply everything in this equation by 10x. Remember, when you multiply fractions by whole numbers, you just multiply it in the numerator. So we're doing 10x times 1. That's 10x. We're still going to have to divide it by the 2x, but we'll do that on the second step. We'll just kind of keep our current path going. Plus, 10x times 3 is 30x over 10 equals 10x times 1 is 10x over 5x. Cool. Now, we're going to simplify all these, and there won't be any more fractions. 10x divided by 2x. The x's cancel. 10 divided by 2 is 5. 30x divided by 10 is just 3x. And then here, again, the x's will cancel. 10 divided by 5 is 2. Look at that equation. 5 plus 3x equals 2. Are you kidding me right now? We can do that, no problem. We're going to subtract the 5. 3x equals 2 minus 5 is negative 3. And then we'll go ahead and divide by 3, which gives us x equals negative 1. That is the correct answer. Now, again, thinking future, we're going to have some extraneous solutions where when you plug them back into the original, they don't work out. Here's always the problem. You can't divide by 0. So we have to think, where in the denominator could x equal 0? Like here and here. What would that x have to equal for that denominator to equal 0? And the only thing it cannot equal is 0, because 2 times 0 is 0, 5 times 0 is 0. That's easy. So if you ever see x in the denominator and it's just being multiplied by something, x could not equal 0. We're going to end up having problems later where it's like x minus 4 in the denominator. And like, what would x have to equal for this denominator to equal 0? It would have to equal positive 4, because 4 minus 4 is 0. Those are things to consider. Also, if it said like 1 over x plus 6, x cannot equal, it's always the opposite of what it looks like. If you see x plus 6, x could not equal negative 6, because negative 6 plus 6 is 0. You can't divide by 0. So I usually have students figure out those excluded values before they even start solving it. Like, get it in factored form when necessary. You can't factor anything on here. So then I'm just thinking like, x cannot equal, the only x I see in the denominator is there. And if it's patched up with multiplication there, it just can't equal 0. So if I end up getting the answer of 0, I know it can't be 0, so that's where I would say no solution if that happens. So let's go ahead and multiply by a common denominator here, something that 3, 3x, and 6 all go into. Now, if you can't think of the least common multiple, what you can do is you can always multiply all of them together. 3 times 3x is 9x, times 6 is 54x. You can use that, and it'll work. But there's a smaller one. They all go into 6x. So if you can find the least common multiple, it's just lighter work. 6x times 1 is 6x. We'll divide by 3 on the next step. Plus 6x times 1 is 6x over 3x equals 6x times 1 is 6x divided by 6. So now we'll simplify all these. 6x divided by 3 is 2. Here, again, the x's will cancel out. Oh, sorry, I forgot my first x. Oh, goodness. I'm so embarrassed. 6x divided by 3 is 2x plus 6x divided by 3, x is just 2. And then over here, 6x divided by 6 is 1x. Now we have x's on both sides of the equal sign, so we could go ahead and get this 2x out of here by subtracting it. Those would cancel. We have 2 equals 1x minus 2x is negative 1x. And then we could just divide by negative 1. 2 divided by negative 1 is negative 2. Double check that that is not one of your excluded values. We're good. The only thing x could not equal was 0. We got negative 2. We're gold, pony boy. If you look at b, there's a couple c's in the denominator. It doesn't have a plus or minus with it, meaning it can't equal 0. That's it. That's the only excluded value here. So now we can go ahead and multiply and clear the denominators. It has to be something that c, 2c, and 5 all go into. Well, 2 times 5 is 10, and it's going to need to have a c. So we'll use 10c. We're just going to multiply these in the numerator. 10c times 4, 40c over c equals 10c times 3, 30c over 2c minus 10c times 1, 10c over 5. Let's simplify all of them. 40c divided by c, the c's will go away, 40. 30c divided by 2c, c's will go away, 30 divided by 2 is 15, and 10c divided by 5 is 2c. Now we got to get rid of that 15. Now some people see the minus after it and they're like, oh, let's add 15. But 15 plus 15 isn't 0. We're trying to 0 it out. The negative goes with the 2c. So we're going to have to subtract 15 to get rid of the 15. Because 15 minus 15 is 0. 40 minus 15 is 25 equals negative 2c. And I'm beginning to see... Get it? You got it, right? Okay, good. We'll divide by negative 2 there. Nice thing about these is you just leave them improper. 25 over negative 2, just scooch the negative up top. Negative 25 halves. You don't need to do the decimals. Just leave it as a simplified improper fraction. Make sure it's not an excluded value. We're good! All good, baby! What else do we have? Oh! I look at our denominators. I see some x squared, some x's. There's no plus or minus in the denominator with it, so our excluded value would be 0. We're going to multiply by a common denominator. Our only denominators are x squared and x. They have a common factor of x squared, or not a common factor, least common multiple. So we're going to multiply everything by x to the second power. So that would give us 5x to the second power over x to the second power equals 6x to the second power over x minus x squared. There we go. All right. So 5x squared divided by x squared, the x squareds will cancel. 5. 6x squared divided by x to the first would just be 6x. And then we have the minus x squared. Now, this one's going to require some factoring to solve it. I mean, you could do quadratic formula, all that stuff. I wouldn't. But in order to solve by factoring, when you have the x squareds and x's and regular numbers, you want to get it equal to 0. So we're going to get everything onto the left side. So we're going to add x squared to both sides, and we're going to subtract 6x. That'll totally zero out the right side. So we'll have x squared minus 6x plus 5 equals 0. Man, good thing we're professional factorers. That left side would factor to x minus 5 times x minus 1. And if you remember back in the day when we solved by factoring, if it said x minus 5 as a factor, that means our answer would be positive 5. And that's from the zero product property. X minus 1, that means x would equal positive 1. So we got two different answers there. That's cool. They both work in the original problem. Let's check if it's an excluded value. Oh, we're good. The only thing it couldn't equal was 0. We're gold. We're doing great. was pretty tough. Oh yeah. This is about to get real exciting, guys. Real exciting. Just did that one. We're going to skip A and hop to B. Now, there's only one denominator here. And remember, the denominator cannot equal 0. So if it says t minus 1 in the denominator, that means we're going to have an excluded value where t cannot equal positive 1. Because if it equals 1, 1 minus 1 is 0. You can't divide by 0. Great. Got that handled. So now let's go ahead and multiply by a common denominator. The only denominator is t minus 1. So we're going to have to do t minus 1 times the t minus 2 over here. On the right side, check this out though. If we're doing t minus 1 times 8 minus 2t and dividing by t minus 1, what's going to happen with those t minus 1s over there? They're going to cancel out. So all we're going to have on the right side is 8 minus 2t. The left side, we are going to have to factor or FOIL it out. So t times t, t squared. T times negative 2, negative 2t. Negative 1 times t, negative 1t. Negative 1 times negative 2 is positive 2. So if we clean that up, combine our like terms, we'll have t squared minus 3t plus 2 equals 8 minus 2t. Again, this is going to require some factoring, and when that's the case, we're going to have to get everything on one side. So I'm going to add the 2t to get rid of it over there. I'm going to subtract the 8, and then that cancels everything on the right side. Over on the left side, we'll have t squared minus t minus 6 equals 0. All right, I see it ends in minus. I know that has to be a positive times a negative. I know they have to be the middle apart. Factors of 6 that are 1 apart would be 2 and 3. To make them add up to negative 1, it'd be minus the 3 plus the 2. We're ready for our answers. It says t plus 2. That means t would equal negative 2. It says t minus 3. That means t would equal positive 3. Boom. Either of those excluded values? No. The only thing it could not equal was 1, so we are good to go. Here we go. Here we go. Oh! The work rate problems. Story problems. Fun. Max can wash and wax a car in 60 minutes. His older sister Kayla can do the same job in 45 minutes. How long will the car take them if they work together? So, it's always the same formula with this. It's like, in this case, who do we have? Max. We're going to have Max plus Kayla equals both. Now, it takes Max 60 minutes to wash the car. So we're going to write that as a fraction. Because every minute, he can technically wash 1/60th of the car, if it takes him 60 minutes to do it. So you put their rate in the denominator. So Max took 1, we're going to say 1 over 60 for Max. Plus, Kayla does it in 45 minutes. She's just that good, so we'll say 1 over 45. How long? We don't know how long it's going to take him. That's our mystery time. So we're going to put 1 over x. You could say the excluded value is 0, but if you end up with 0 as an answer, and you're like, it took them 0 minutes working together, that just doesn't even make sense anyway. Now, we need a common denominator. We could use 180, but let me show you another way you can do it. So like I said earlier, you can always just multiply all of them together. You could say like 60 times 45 times x. And let me show you why that's nice in something like this. If these are all getting multiplied by 1 in the numerator, look at this first fraction. 60 times 45 times x times 1 is 60 times 45 times x over 60. Those 60s are going to cancel out here in a second. Plus 60 times 45 times x over 45. Huh? See anything that's going to cancel out? Equals 60 times 45 times x over x. All right. Now we'll have those common factors. The 60s will cancel out. We're left with 45 times x, that's 45x. Plus, the 45s cancel out. 60 times x is 60x. Here, the x's cancel out. 60 times 45, that I don't know. Let's see, 45 times 6, 30, 270. Oh yeah, that makes sense. And then we'll have to throw a 0 on that. So 2,700. Now, on the left side, those are both x's. So we can make that 105x equals 2,700. And then we would just divide by the 105. I don't know, man. 2,700 divided by 105. I'm going to guess like 24-ish. But what do I know? 2,700 divided by 105. 25.7. That's rounded. It doesn't say where to round it, so we'll just cut it off there. It's going to take them about 26 minutes working together. And they're going to have fun and they're going to bond. Good old Peggy can pick a bushel of apples in 45 minutes. Peter can pick a bushel of apples in 75 minutes. How long is it going to take them both to pick a bushel if they work together? So, old Peggy is 1 over 45. Plus, Petey Pants is 1 over 75. How long together? Now, obviously, the ladies are better than the men at everything here, right? They picked the bushel faster than us. They cleaned the car. Come on, men. We can do this. We can do this. The ladies are great. All right, so we're going to multiply by a common number here. I don't even want to figure out what 45 and 75 can go into. I'm just going to multiply by 45 times 75 times x. 45, 75, x over 45 plus 45 times 75 times x over 75 equals 45 times 75 times x over x. Here the 45s cancel, we got 75x. Here the 75s cancel, we have 45x. Here the x's cancel, 45 times 75, I'm glad I grabbed the calculator, 3375. Cool. So if we add these x's together, that would give us 120x equals 3,375. We'll divide it by the 120. Let's see, divided by 120. 28.125. 28.1, what was it, minutes? Yeah, nice. That wasn't too bad, right? All right. Watch this move. You ready for this? I'm just walking across. All right, we're back. So if you look at this one, we have a little more complicated fractions here. So I would check for excluded values first. That's where in the denominator do you have an x? I see one over here on the left, and it's x all by itself, which means it cannot equal 0. This other one that says x plus 4, that means x could not equal negative 4, because negative 4 plus 4 is 0. You cannot have the denominator equal 0. So we got 0 and negative 4. Handle that first. Now, if you just have one fraction equals one fraction, probably your easiest bet is to just cross-multiply them like you did with old proportions way back in the day. So we would do 2 times the x plus 4. I would set it up like distribution. Equals x times 1 is just x. So we could distribute there. 2 times x is 2x. 2 times 4 is 8. Okay. 2x plus 8 equals x. Heck, let's get wild and subtract 2 x's from both sides. 2x minus 2x is 0, so we have 8. X minus 2x is negative 1x. And then we could just divide by the negative 1. 8 divided by negative 1 is negative 8. Make sure it is not one of your excluded values. Oh, we're good. We're all good. All right. So here, again, all we care about is the denominator because you can't divide by 0. So let's get all our excluded values for both problems here. The first a could not equal 0. The second one could not equal positive 2. A cannot equal 0 or 2. We're back. A cannot equal 0 or 2. On this one, there's only one n in the denominator. It says n plus 1, so that means n could not equal negative 1. Great, we're ready to go. Let's cross multiply. We got 3 times a minus 2 equals a times 5. We could just do that. It's 5a. Go ahead and distribute. 3 times a is 3a minus 3 times 2 is 6 equals 5a. We have to get the a's on the same side, so we can subtract 3 a's. These cancel out. Negative 6 equals 5a minus 3a is 2a. And then we just divide it by 2. Negative 6 divided by 2 is negative 3. Whoops, I wrote x, a. Make sure it's not an excluded value. It's not, so we're all good. All right, we've got our excluded values here. So we're doing n times n plus 1. Ooh, gonna have some factoring to do. Equals 5 times 4 is 20. So if we go ahead and multiply this n times n, it's n squared. N times 1 is 1n equals 20. Let's save a step of writing here. We're going to have to get it to equal 0. How would you get rid of the 20? You would subtract it to get rid of it. So we'll just write minus 20 over here equals 0. Now we're good to go. Factoring this, it ends in minus. So I know it has to be a positive and negative. Factors of 20 that are 1 apart would be 4 and 5. So to make them add up to positive 1, it'd be plus the 5 minus the 4. The answers will look like the opposites. N plus 5, n equals negative 5. N minus 4, n equals positive 4. Check if either of those are excluded values. They're not, so we're all good. All good. Here we go. This is it, the meat and potatoes. All right. I'd recommend you factor everything. So negative 2 over x minus 2 equals, we got x minus 4 over x squared minus 4 would factor to x plus 2 times x minus 2. Now, if I'm getting my excluded values here, I look in the denominator. X minus 2, that means x could not equal positive 2. X plus 2 over here, that means x could not equal negative 2. And then x minus 2 would be positive 2 again. You don't need to list it twice. What we were doing is we were cross-multiplying. Let's try this problem like we were doing the original problems, by multiplying by a common denominator. Now, a common denominator would have to include all parts of denominators. So it would have to include an x minus 2. That handles this and this, but it also has to include an x plus 2. That looks like it's going to be a crazy amount of work. You'll actually see a lot of stuff cancels out, and this will actually be really nice. So we're multiplying these in the numerator. So we'll have up top, we'll have negative 2 times x plus 2, x minus 2. The denominator's still there, the x minus 2. But you'll see that's going to cancel out here in a little bit. Equals, over here we have x minus 4. We're going to multiply it by x minus 2 and x plus 2. And then we keep the denominators x plus 2, x minus 2. Again, that looks like we just did more work for no reason. But check this out. The x minus 2's will cancel out here. So the left side is just going to be negative 2 times x plus 2, which if you distribute that, that would be negative 2x minus 4. The right side, the x minus 2's cancel out, the x plus 2's cancel out, so all we have left is x minus 4. I told you, I done told you it was going to look easier after that. That's not bad, huh? So we could add 2x to both sides. Negative 4 equals 3x minus 4. Then we could add the 4 to both sides. Negative 4 plus 4 is 0. 3x, and then these cancel out. And then there's one more step. You just have to divide by 3. 0 you could divide by 3. It's just 0. So our only answer for x was 0. Is that an excluded value? No. So we're all good. All good. Wow. All right. Looks like we have 2 more. Look at A. If we're thinking about excluded values, the C, the first one could not equal 0. The second one, because we're like setting up equations in our head. So we're like trying to figure out c squared plus 1 cannot equal 0. So you could subtract the 1, c squared could not equal negative 1, and then square root it. And you don't even square root negative numbers. Those aren't even real numbers. So that is all handled. That's fine. So just c cannot equal 0. So we're going to multiply everything by a common denominator, which would have to include c squared, and it would have to include c squared plus 1. That handles all denominators. So this first fraction, I should have just cross-multiplied. That would have been faster. Sorry. So we're going to do 2 times c squared times c squared plus 1 equals, I forgot my denominator, c squared, equals, I'm just going to make that a real thick equal sign right there. Over here we have 2 times c squared plus 1 over c squared plus 1. All these have common factors that will cancel. And that's all we have left. So over here, if we distribute, 2 times c squared is 2c squared. 2 times 1 is 2. On the right side, 2 times c squared is 2c squared. We're like, great. Let's get the c squareds on the same side. Minus 2c squared minus 2c squared. These cancel out. 2 equals, these cancel out 0. What the heck? 2 equals 0. Is that true? No. No solution. Everything else canceled out. Now in this one, the only thing w could not equal is positive 1, because that would make the denominator 0. Now, if we multiply both sides by a common denominator, both denominators are w minus 1. So we're going to multiply by w minus 1. So we have w squared times w minus 1 over w minus 1. Those are both going to cancel. Equals 1 times w minus 1 over w minus 1. Those are going to cancel. W squared equals 1. How do you solve something squared? You do the opposite. You square root it. The square root of 1 is 1, but it can also be negative 1. So don't forget, when you square root numbers, you have to include the positive and negative. So that would be plus or minus 1. The only number that does not have 2 square roots is 0, and then we can't square root negatives in the real number system. You can in the imaginary number system, but that's not as fun.